Welcome to video 6 of Learning C++. In this video, we will talk about pointers and dynamic memory. So, in the memory model of C++, as we've drawn before, variables are just names for memory locations. But those memory locations can also be referenced by address. Each location in memory has a specific number that refers to its location. It's possible to create other variables that store this address and use that to directly access the memory locations. Let's look at this diagram. So we can see that in the stack of main, there are a few variables naming memory, but that memory, rather than containing a value, contains an arrow pointing to another place in memory. These are pointers. Now, B and C point outside of main stack, and we will talk about that with dynamic memory. D points to somewhere in an array, which we've called A, and F points to a number on main stack called E. The heap is where dynamic memory gets allocated, memory outside of the stack. There's a syntax to allocate this memory and to deallocate it. Now let's look at the code. So, as you can see here, we have a new syntax. By placing an asterisk after the type, we've defined a new type, which is a pointer to the first type. So B, C, D, and F are all pointers to integers. We'll see in a moment that A is also sort of a pointer to integers. So, allocating dynamic memory uses this new keyword. Deallocating it uses the delete keyword. By saying new int, we are saying that we want to place an integer in the heap and get a pointer to it. By saying delete B, we're saying that we no longer need that memory. Undefined behavior can happen if you reference memory after it's been deleted, but you should always clean up memory that you're no longer using. Sometimes you want to allocate arrays on the heap. That syntax is simply new int with an array specifier and a size. Arrays are deleted using the delete array operator, which is simply the delete keyword followed by the square brackets. Because the array A is actually a pointer to the first element in the array, you can do arithmetic and assign another pointer, D, to element 3 of A. We'll see here that this will output the value at A3. And in fact, using array index notation, we can access A5 by going to D2. We also have an integer on the stack called E, and we simply get a pointer to it using this new operator, the ampersand. The ampersand simply means address of. Finally, we can also use this operator again, the asterisks before the variable name, to dereference that pointer and output the value. So we should see 13 here. Let's build and have a look. So we're outputting array element 3, array element 5, and E, which is 13. In the next video, we will talk about strings and how they relate to arrays and pointers.